So far, we've talked about finding the expected value or describing the expected value for data sets. Today, we're going to begin looking at visualizing data spread. And in order to do this, we're going to look at creating a second type of graph by hand. So we've already looked at creating histograms by hand, and now we're going to be looking at box plots by hand. By the end of this class, you're going to know the terminology that you need to create a box plot and be able, again, to create box plots to compare the spread and skewness of multiple data sets. So box plots are called so-called because they have a box in the middle that goes from the first quartile or the 25th percentile to the third quartile or the 75th percentile. The median is marked in the middle, and there are whiskers extending to the minimum value in the data set and to the maximum non-outlier value in the data set. We can also mark outliers on the data set. Okay, so before we start drawing our box plot, we are going to start with the basics and just look at finding the range quartiles and the inner quartile range by hand. Okay, so range is a very simple statistic to calculate. It's also one of the, it's the most basic way to tell how spread out a data set is. And it's just the difference between the minimum value and the maximum value of the data set. So in order to, if we look at this example here, we've got two forensic science technicians who are testing crime scene samples. The number of minutes needed to test samples for 11 different samples was collected. And we're going to determine the range for each of the data sets. So for Tech A, we're just finding the range. So we're going to go and we're going to pick out the maximum value that they have and the minimum value. And so then for Tech A, the range, there's no special symbol for range. It's just going to be given by the maximum minus the minimum. So it's going to be 6. And the units for range match the units in the question. So we know that the number, this data set is the number of minutes needed to run a test. So the range for Tech A would be 6 minutes. Okay, so you can do the same for Tech B. If we think about Tech B, again, we find the maximum value in the data set and the minimum data value in the data set. And so the range is given by the maximum minus the minimum. And so in this case, it would turn out to be 12 minutes. Okay. The larger the range for a data set, the more spread out it is. Excellent. Okay. So range, fairly straightforward. Again, no special symbols there. So the next thing we want to look at calculating are our quartiles. So we can think about our data set as being spread or divided into 4 equal parts. So on the low end, we have the minimum. On the high end, we have the maximum. Right in the middle, at the 50th percentile, we have the median. We can also refer to the median as Q2 or the second quartile, the 50th percentile. Okay? So how we find Q2, how we find the median doesn't change from what we talked about in the previous module lesson. We order the data and we find the middle value. Okay, so what's new here are we've got the first quartile, Q1, which is the same as the 25th percentile. And now the 25th percentile, Q1, is the median of the first half of the data. Okay, so we find Q1 after we find Q2, after we know what the median is, because we're going to divide the data set in half again. And then Q3, and fairly straightforward, it's the third quartile, and it's going to be the median of the top half of the data. So we're going to find the median of the top half of the data to get that 75th percentile, or Q3, from our data set. So we'll go through a couple different examples because we will remember how we find the median changes a little bit depending on the size of our data set. So let's get started with some examples. So for example A here, the first thing I notice is my data set's not sorted. Before I find a median or Q1 or Q2, we need to start ranking our data. So we're going to order it from lowest to highest, and we just carefully go through the values and make sure we've considered them all. Okay, we're going to pay attention to how large our data set is. So here I have 11 pieces of data. So you'll remember that for an odd number data set, the median value is given by the middle value. No averages needed. So Q2 is equal to 6 in this example. Okay, to find the Q1, the 25th percentile now, we're going to take the first half of the data. When our data set has an odd number of values in it, we're not going to include the middle value in either the lower half or the upper half. So my lower half of the data is just going to consist of the 5 values less than the median value. Okay, and so then I can find the median of that first half, and that's going to be my Q1 value. To find my third quartile value, my 75th percentile, my Q3 value, again, I'm going to look at the upper half of the value because we've got an odd number of values. I'm not going to include the median value. And I'm going to find the median of the top half. Top half has 5 values, so I choose the third value. My Q3 value is 9. So I found Q1, Q2, Q3 for the first data set. Okay, let's do this again for example B. Notice that we have 12 pieces of data, so how we find the median, how we spread out the lower half and the upper half of the data is going to be a little bit different. First step stays the same though. Our data is not ranked, so we need to order the data. Right, so sorry, I misspoke before. We have 10 pieces of data in this data set. So now that our data is ordered, we're going to find the median to begin with. So because we have 10 pieces of data, our median is found by averaging the 5th and 6th values. So Q2 in this case is equal to 5.5. Because we have an even number of values in our data set to find the 25th percentile, the first quartile value, the Q1 value, we're going to look at the lower half of our data. We're going to take the lower 5 values in our data set and find the median of that. And so Q1 is equal to 4. Similarly, we're going to, in order to find the third quartile, the 75th percentile value, Q3, we're going to look at the upper half of the data. That's the upper 5 values in our data set, and find the median of those values, which would be equal to 7 for this data set. Okay, great job. So let's do one more example, and this time we're going to look at a data set that has 12 pieces of data in it. So again, we've got an even number of values. So when I'm finding my median value to begin with, Q2, I'm going to be finding it by averaging. In this case, I'm going to be averaging the 6th and 7th piece of data. Oops, I've got to always remember to order our data first. So let's rank our data, and then we'll know which is the actual 6th and 7th piece of data. Okay, we're ready to go now. So our middle value is going to be found by averaging 6 and 6. So Q2 is equal to 6. Now, again, when we have an even number of values in our data set, we're going to find the lower half by taking the lower half of the values. Every value gets included in either the upper half or the lower half when we start off It's an even number of data values to begin with. So my lower half is the lower 6 values, and I'm going to find Q1 in that case by averaging values 3 and 4. So my Q1 value is 4. I'm going to find my 75th percentile, my third quartile value, my Q3 value in this case, by looking at the middle two values in that upper half of the data set. So my Q3 value is equal to 8. Okay, so now you've seen how to work with finding first, second, third quartile values for data sets of different sizes. It's not too hard, but it is important to pay attention about where the middle should be. Okay, before we finish off this, this part of the notes and go on to doing some application questions, one more term to introduce. We've got the interquartile range. So the interquartile range is just the distance between the first quartile and the third quartile value, and it tells us how big of a range the middle 50% of the data lies in. So once we calculate a Q3 value and calculate the Q1 value, the difference between them is referred to as the interquartile range. Okay, if you have any questions about this, don't hesitate to contact your instructor or attend their office hours. And we'll be right back with the next notes on 5-number summaries and starting to create box plots.